Find the coordinates of the point which divides the line segment joining the points -1, 7, 4, -3 in the ratio 2:3. To understand this, let us have a look at the graph, how it looks like. This is point A and this is point B. We need to find a point on this line such that the ratio of this part and this part is 2:3. So let us say that this point is PXY. So to find this point, we have a section formula. Using that formula, we will find the point. This is called the section formula. The coordinates of the point PXY, which we have to find, which divides the line segment joining the points A, X1, Y1. So this is X1, Y1, and B, X2, Y2. This as X2, Y2. Internally in the ratio of m:n. So we will take this as m and this as n. So let us substitute in this formula. mx2 means m is 2, 2 times x2, x2 is 4 plus nx1, n is 3 and x1 is -1 divided by m plus n means 2 plus 3, comma, the y coordinate is my2, 2 times y2 is -3 plus n is 3, y1 is 7 divided by 2 plus 3. 2 times 4 is 8. 8 minus 3 divided by 2 plus 3 is 5. Now 2 times -3 is -6. 3 times 7 is 21 divided by 5. So this can be written as 8 minus 3 is 5 divided by 5, and -6 plus 21 is -15 divided by 5. So 5 divided by 5 is 1, and 5 1 times, 5 3 times, -3. Sorry, plus 3. This is plus 15. So the point which divides the line segment in the ratio of 2:3 is 1:1, 3. Now let us see how this point will look like in the graph. See, this is the exact point which divides A and B in the ratio of 2:3. Find the coordinates of the points of trisection of the line segment joining 4, -1 and -2, -3. So we have to understand that what is the point of trisection. The point of trisection are the points which divide the line segment into 3 equal parts. Let us have a look at the graph of these points of trisection. So this is first point A and this is B. So we have to mark 2 points on this line which divides this line AB in 3 equal parts. This is first part, second part, third part. So we have to find this one and this one. Here what we have to understand is, suppose let us consider thus we don't have this point Q. We have only point P. So point P is dividing the line AB into the ratio of 1:2. This is one part, these are 2 parts. So point P is dividing the line segment in the ratio of 1:2. Similarly, if we assume that there is no point P, if you look at point Q is dividing the line segment into one part and 2 parts. So this is dividing in the ratio of 2:1. So for points of trisection, we have to consider the ratio as 1:2 and 2:1. Let us solve this further. The point P divides AB in the ratio of 1:2. So let us say 1 is M and 2 is N, and this is X1, Y1, X2, Y2. So now we will solve this using section formula. The coordinates of the point P, XY, which divides the line segment joining the points A and B internally in the ratio of m is to n are mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. So let us substitute the values in the formula. So here m is 1, 1 times x2, x2 is minus 2, 1 times minus 2 is minus 2, plus nx1, n is 2 and x1 is 4, 2 times 4 is 8, divided by m plus n, 1 plus 2 is 3. Again my2, m is 1 and y2 is minus 3, so 1 into minus 3 is minus 3, and ny1, 2 into minus 1, minus 2 divided by 3. So 8 minus 2 is 6, 6 divided by 3, 6 divided by 3 is 2, minus 3 minus 2 is minus 5 divided by 3. So this is point P. Now let us find point Q, which divides A and B in the ratio of 2:1 using the same formula. The only change here is this point is Q, we have to find Q, which divides in the ratio of 2:1. So m is 2 now, n is 1. x1 and x2, y1 and y2 are same. So let us substitute and find the value of Q. mx2, m is 2, 2 times of x2 is minus 2, which is minus 4, plus nx1, 1 times x1 is 4, which is 4, divided by m plus n is 2 plus 1, 3. Again my2, 2 times of minus 3 is minus 6, plus ny1, 1 into minus 1 is minus 1. So let us write this as minus 1, divided by m plus n is 2 plus 1, 3. Minus 4 and plus 4 is 0. So 0 divided by 3 we can write 0. Minus 6 minus 1 is minus 7 divided by 3. So this is point Q.